Welcome to another exciting episode of the Magna Podcast. I'm your host, John.
And I'm Amy.
Today we're talking about magnetic therapy. You've handed us a stack of articles, and we're ready to plunge into magnetic therapy.
Yep.
Our mission today is simple, really. Cut through the noise, give you the essentials. What is it? What could it do? How's it supposed to work? And, what does the science actually say? We're aiming for well-informed, not overwhelmed.
Exactly. And it's worth noting right off the bat why this is a topic so many people are interested in. I mean, chronic pain is just, it's everywhere.
Oh, yeah.
We saw figures, didn't we? Australia, around 2018, like 16% of people dealing with it.
16%, wow.
And the U.S., back in 2016, it was even higher, over 20% of adults.
That's huge.
Yeah. So when you've got numbers like that, it's totally natural. People start looking beyond, the usual stuff. And the fact that some clinical trials actually suggest magnetic therapy might help with various painful conditions, well, it makes it worth a closer look, doesn't it?
It really does. Okay, let's unpack this then. Magnetic therapy, basically, is using static magnets, the ones with a constant field for pain relief, helping recovery. Our goal here with this deep dive is to give everyone, whether you're thinking about this for yourself or you're like a pro in the field, a solid handle on the basics and maybe some of the trickier bits.
Yeah, right. So let's kick off with the reported benefits. What are people actually saying this stuff does? The sources you share, they list quite a range.
Absolutely. Pain relief is obviously the big one for most people.
Yeah.
But the articles also mentioned it could be a helpful add-on, an adjunct therapy for things like MS, different kinds of arthritis, osteoarthritis, rheumatoid arthritis, tissue and bone injuries, even neuropathy. What I found really interesting, though, was the mention of potential benefits for psychiatric disorders, sleep problems, stress, even really specific stuff like genital pain, post-polio pain, and just general chronic pain syndromes.
And what keeps popping up is this idea of anti-inflammatory effects. That could be key, couldn't it? Inflammation is involved in so many of these conditions. If something could genuinely tackle that, that'd be pretty significant.
Totally. And when you look at what users and practitioners are actually reporting, it gets even more specific. Things like better circulation for old injuries, which kind of makes intuitive sense, right? But also less circulation and swelling for things like fresh sprains.
Interesting. So different effects for different situations.
Yeah, seems like it. Then there's the general idea of reduced inflammation, this intriguing concept of correcting energy imbalances, whatever that fully means.
We should probably circle back to that one.
Definitely. And also boosting immune function, better sleep, less stress, and the main event for many, pain going down or even stopping completely.
Yeah, but it's crucial, isn't it? The sources really stress that getting real benefits probably means using scientifically developed magnetic devices.
Right. It's not just sticking any old fridge magnet on and hoping for the best.
Probably not, no.
Which, naturally, leads us to the massive question.
Yeah.
Okay, fine, but how on earth is this supposed to work? What's the actual mechanism?
Well, yeah, the articles make it pretty clear there's no single simple answer. It looks like effectiveness depends on a bunch of things working together.
Like what?
Like the specific health problem, the design of the magnet, how the poles are set up, how strong the field is, how you actually apply it, and maybe most importantly, these things called magnetic field gradients.
Magnetic field gradients.
Yeah.
Okay. And you mentioned magnetic fields are vector quantities. So it's not just strength, but direction matters too.
Exactly. And different materials, plus the magnet size, affect both the strength and, crucially, how deep that field penetrates into your body.
Right, okay.
And this is where it gets really interesting talking about these multipolar magnets like the Q magnets mentioned. These aren't your standard north-south bar magnets. They're designed to create these complex patterns, these gradients. And research suggests these gradients can affect charged particles in the body and, importantly, our nerves very differently than simple bipolar magnets do.
Okay, so bottom line, not all magnetic therapy gizmos are the same. A weak fridge magnet won't do much therapeutically.
Seems very unlikely.
And what works for one person, or one specific ache, might do nothing for someone else, depending on all these different factors.
That's a really fundamental point, yeah. Now let's look at how it's being researched and actually used. The source mentions tons of different devices out there, bracelets, insoles.
Wraps, braces, pillows, mats, blankets, the whole shebang.
Right. And the articles, they kind of sidestep endorsing some of the, let's say, less scientifically backed ways of using them, but they do outline 3 general approaches people take.
Okay, what are they?
Well, first there's magnetic jewelry. The idea is it influences the body's overall energy flow. Interestingly, the source itself says they don't sell those.
Telling, perhaps.
Maybe. Then there's applying just one pole north or south to specific spots. Could be the painful area, acupuncture points, even the belly button. The articles mention another piece goes into the history and evidence or lack thereof for that specific polarity approach.
Okay, and the third one?
The third one, which the source really highlights as having the most research and data behind it, is placing magnets on very specific points, typically right over nerves, joints, or the injury site itself.
Ah, the targeted approach.
Exactly. That seems to be where the strongest evidence is stacking up.
That makes sense, doesn't it? Focusing the effect right where you need it. And it was interesting seeing that recommendation from Dr. Daniel Claw, the rheumatologist. He basically said, maybe try a single magnet on the spot before shelling out for a whole magnetic mattress pad.
That's really practical advice, actually.
Fair.
Focus first, see if it helps. And again, the source hammers home that it's not just about whether the device is comfy, it's the type of therapeutic magnet inside that really matters for effectiveness.
And this is where that Vanderbilt University research comes in, which sounds pretty key.
It does.
They apparently found that the common bipolar magnets you find in, say, bedding or simple wraps, they might not actually do much to the nerve pathways that carry pain signals.
Right. But crucially, they contrasted that with the magnetic field gradients from strong quadrupolar magnets.
Ah, the multipolar ones again.
Yeah, they suggested those gradients do seem to have a more noticeable effect on those nerve pathways, which really drives home the point. Magnets aren't just magnets. The technology, the design, it seems really critical.
So let's dig into the materials then. What are these things actually made of?
Okay, broadly, the source splits them into electromagnetic ones, needing electricity, and static ones, which are permanently magnetic.
Right.
And within static magnets, they point out three main types based on strength, or technically their energy product.
Okay, so we've got the rubberized flexible ones like fridge magnet, weak, low energy product.
Pretty weak.
Then ceramic magnets, a step up, moderate strength.
Moderate.
And then the big guns, rare earth neodymium magnets.
Yeah.
Very strong, high energy product.
Exactly. But, and this is important, the strength and how deep it goes isn't just about the material.
Right. Size and shape matter too.
Hugely. You could have a tiny, super strong neodymium magnet, but its field might drop off really fast just a short distance away.
The articles had that great comparison, didn't they? Earth's magnetic field, pretty weak, like 0.5 Gauss, but it affects a compass on a plane.
Right.
Then you take a small rare earth magnet, maybe 3,000 Gauss at the surface, way stronger, but a meter away, it does nothing to the compass.
Precisely. So just quoting Gauss or Tesla doesn't tell the whole story. And just for perspective, 1 Tesla is 10,000 Gauss. So when we talk about thousands of Gauss or over 1 Tesla, these are pretty strong static magnets we're dealing with.
Good context.
And it's worth noting the mention of Neuromagnetics, the parent company of Q Magnets. The source positions them as leaders in researching and developing these multipolar magnets, working with scientists, publishing studies, adds a layer of credibility,
Definitely. Now, polarity, that comes up a lot. The source clarifies all magnets are bipolar, north and south.
That's just physics, yeah. And sometimes you hear unipolar in magnetic therapy. That usually just means they're using a bipolar magnet, but only putting one side, say the North Pole, against the skin. The magnet itself still has both poles.
Gotcha. And multipolar.
That refers to devices designed so both North and South poles face the body, often in a specific pattern.
And the article warns against simplifying it, right? Like north is good, south is bad or something.
Exactly. It's likely not that simple. Then the source gives a concrete example. The quadrupolar Q magnet.
Okay.
It's multipolar, specifically quadrupolar, 4 poles on one side, made of strong, rare earth neodymium, high Tesla rating 1.35 Tesla, which is 13,500 Gauss, high energy products, N45, 4 alternating poles on one face.
And this connects to that old research you mentioned, McLean and colleagues, 1991.
Yes, they had an image comparing 5 different magnetic setups on nerve tissue in a lab dish in vitro.
And what did they find?
What's really striking is that the quadrupolar array, the one with the 4 alternating poles, apparently completely blocked the electrical signals, the action potentials, in the nerve tissue within minutes, even when they cranked up the stimulation.
Blocked the nerve signals.
Yeah. These action potentials are how nerves talk. And other setups, like just 4 north poles or 4 south poles, had different, less dramatic effects, or sometimes no effect at all. And importantly, the nerve activity came back when they took the quadrupolar magnet away.
That's pretty dramatic for a lab study.
Yeah.
It really suggests the arrangement of the field, the multipolar design, can have a fundamentally different impact on nerves compared to simpler magnets.
It really does. It highlights how sophisticated magnet design can be and why it's not just about raw strength. The pattern, the gradients seem absolutely critical.
Okay, so let's start pulling this all together. Based on everything we've looked at in these sources, what are the main conclusions?
Well, the source strongly suggests magnetic therapy can potentially relieve pain by acting directly on the nerves. It also hints at a possible molecular action, maybe reducing inflammation, which could then help the body's own healing processes.
But, and this is the big but, we keep coming back to, it really depends on using the right kind of magnetic devices and applying them correctly, using proper methods or protocols.
Exactly. And based on the clinical trials the source reviewed, it seems these multipolar therapeutic magnets show the most promise, the most effectiveness.
Right.
The source really emphasizes, needing to understand and visualize the field that your chosen magnet actually produces.
So it needs to create those steep enough magnetic field gradients to actually reach and affect the target tissue you're trying to treat.
Yeah.
It's not enough for it to be strong just on the surface.
Precisely. The field has to get to the tissue and interact with it meaningfully.
Okay. Now, beyond the main stuff, you also gave us that list of related article titles. They seem to dive into even more specific areas.
Yeah, they give you a taste of the wider conversation, things like comparing magnetic therapy versus grounding, articles debunking myths about blood flow.
Oh, yeah, that's a common one.
Right. Reports on positive studies for neck and back pain, that title, Static Magnetic Field Therapy Effectively Relieves Neck and Back Pain, seems pretty direct. Discussions on using Q magnets for ACL recovery, an article tackling, unfair stigma against magnetic therapy in the media, and that why magnet design matters, learning from cow magnets title is just intriguing.
How magnets, okay. There are also titles like Breakthrough in Fibromyalgia Treatment, stuff about magnetic mattress pads for pain sufferers, the role of the sympathetic nervous system in chronic pain, and how Q-magnet therapy might fit in. Even a Q-magnets case study published in a medical journal.
And for the real tech heads, there are resources on magnet manufacturing, commentary on media portrayal, links to credible research agencies, lots more to explore if this deep dive has piqued your interest.
Definitely. So wrapping up this deep dive on magnetic therapy, based on these sources,
Yeah.
the main takeaway seems to be, well, it's not just woo-woo. There's actual evidence suggesting that magnetic therapy, especially with these more advanced multipolar designs and when used strategically, holds real promise for pain relief. It's definitely a field worth continued scientific digging.
Absolutely. But it's crucial to remember, effectiveness isn't just about how strong a magnet feels. It's complex. It involves the specific magnet type, its engineered design, how it's applied, and the condition itself. So many factors.
Which leads us nicely to our final thought for you today, thinking about the long history of magnetic therapy alongside this newer research into complex magnet designs. What other established health ideas might be worth revisiting? With a critical eye, but also open to new science.
Good question.
And maybe more importantly, how can you evaluate this kind of information critically? How do you sort anecdotal stories from solid scientific findings and really get the nuances of the science? Definitely something to mull over. Thanks for taking this deep dive with us.
Thanks for tuning in, everyone. Stay curious, and we'll catch you next time.